أستاذنا الدكتور علاء علما. أنا هحاول كده أقول يعني very brief bio. He has a lot of history and he was one of the pioneers of our HVAC community in Egypt. First thing, he is the past president of ASHRAE CAIRO chapter, and he is an author of one of the great engineering books, which is the district cooling guide. And he is, of course, the head of the HVAC code committee with the HRBC. And we have the honor that he is in the RT committee of the United Nations. Please.
Good evening. It's a pleasure to talk to you. Allow me to speak in English and in Arabic. We have some honored guests with us here from the United Nations, from several parts, from Ukraine, from other parts of the world. So I'll talk a bit in English and a bit in Arabic, and I'll try to give you in 30 minutes or less an idea of a project that we started 4 years ago. And this project is pivotal because there hasn't been any project similar to it that has been done for the Egyptian industry ever. The idea of the project is to find a system of cooling, air conditioning. I don't want to say cooling because cooling now means many things, but an air conditioning system that can compete with the DX unit, DX air conditioning, direct effect air conditioning, air cooled, so that the efficiency is higher, the EER is higher, and the capacity is similar to that of a DX unit. So the idea is, in the end, is to assist in finding a system that is more efficient, has a higher IRR, has a better performance than a DX machine. Because a DX machine, an air-cooled DX air conditioning machine, is a unit that uses a lot of power, a lot of electric power, to be able to provide cooling. So the United Nations, represented by UNIDO, have gracefully assisted the Egyptian industry to produce a unit, prototypes, and compare those prototypes with a similar CFM unit operating with the DX theory. In other words, because we don't have labs in Egypt that can test the performance of a unit that works with direct and indirect evaporative cooling, we decided to do the test in situ in one of the 8 climatic zones of Egypt. The climatic zones of Egypt, according to the code, the energy code of Egypt, are 8. And I'm trying to give you an idea of what you are going to see to make it easier for me to skip quickly the presentation because it's only half an hour. So because we have 8 climatic regions in Egypt, a unit that operates on the theory of evaporation of water will not perform well in all those different climatic zones. Because the unit makes use of the evaporation of water to decrease the temperature, the dry bulb temperature of the air. To be able to do that, we have devised with the great Egyptian manufacturer of air conditioning, central air conditioning rather than split. Because if you look at the machine, and I'll show you how it looks like here, the machine is actually an air handling unit of sorts, with a bit of modification in it. So we asked the 6 manufacturers. We didn't realize there were 7 actually. Now we know, yesterday I knew that there is an next set of manufacturers that enter the ring, but we didn't know at the time. So we asked the 6 manufacturers of central units to create prototype that have the similar CFM as a DX machine. And then we put in 2 of the climatic zones of Egypt, 2 of them manufactured together the same day and seen the result. And then the next day, 2 more. So actually 4 participated with us with machine. The other 2 didn't have enough time to produce the prototype. So those 4 were tested at climatic zone 2. And then the same 4 were tested again in climatic zone 5. And those results I'll show to you, and I'll prove to you, and we have here, we have the great honor to have some of the manufacturers with us today. I'll show you that this theory works, and works very well, and is quite efficient. So enough talking about the project, let's go to the project itself and see how it looks like. Now, there is a bit on testing and strategy, which I think I talked about. I want to say here that is it finished? Or the battery is finished? So the HVAC, our National Center, National Building Research Center, has made all the empirical formula, testing formula for the test, HVAC, and we have here with us Dr. to be Sally Alaeddin, who was there at all the tests. She's a very efficient lady and she's done a very good job with her team. And Dr. Sayed Shibr, who's the head of the Institute in HVAC, was supposed to come today, but he had an operation, a dental operation today, so he said he's sorry he can't come, so I'm going to talk about the bit that he was supposed to talk about. You will see in this coming bit how the unit were placed one next to the other during the test, and then you will see how we tested them and how we took the value of the test. And then after that, we added a new dimension to the test. We asked Mr. Hussam Heba, who's now the Minister of the GAFI, which is the Authority of Investment, to do the testing protocol or a formula for seeing which of the 2 systems are better than the other from a financial point of view. So they made a program during the lifetimes of the 2 units that is around 15 years, and they found out using the capital cost of the machine and the operating cost of the machine, of the DX machine and the IEC/H, which is an evaporative cooling machine, hybrid, and I'll tell you why hybrid very shortly. Which of the 2 have a better or a lower net present value? By definition, a unit such as an IEC-H unit will be more expensive than a DX machine because it has more equipment and it's not produced on a mass production range like a DX machine. So he made this program where he would put the capital cost, which is more expensive for an IEC machine, and then see the operating cost over 15 years. And when, with the discount method, he calculates the price of the machine today, after 15 years of running the machine, the one that costs less is a better machine. As long as the efficiency is higher and the capacity is as good as or higher than that of the other one. And this is what we are going to prove. So those are the figures that more or less what I talked about. And this is how the machine was stacked. One next to the other. On the right is the DX machine. On the left is the IEC machine. And Sally and her group took all the results. And we made sure that both machines operate at the same CFM, at the same rate of discharge, by using variable speed drive on the IEC unit to match the DX unit. Both units are air-cooled. Those are the 5 climatic zones division. We tested as the blue, as the green area, not the very top one. The very top one is on the coast, and this is very humid. But the darker green one, is across CAIRO, east and west, and all across Sinai. So those we tested in this climatic zone 2. And we tested as climatic zone 5, which is around the Red Sea. Why those 2 limits? We tested in those 2 places to see how well the unit will fare in a place where the humidity is high, not as high as the coast, but just some days higher. And 5, because 5 is hot, high dry bulb temperature, but lower humidity. We are hoping to test at climatic zone 8, which is the very south, because there at the very south it will do very well, because the humidity is very low and the dry bulb is high. But this is where we tested that. Those are pictures of the tests themselves when they are conducted. And then we move to the technical and financial part of the study. Now, on the financial part, as I said, our guiding principle is the net value, net present value of the unit. To be able to get the net present value, a program was made by Mr. Hussam Heba. Here is part of the program, 15 years. We calculate the different part of the program, which is the cost of the capital cost of the machine, the number of hours the machine will operate, which we call EFLH, equivalent full load hours. And we operate on this equivalent full load hours, which is the number of hours that the machine will work at full capacity per year, per 8,750 hours. And we chose a ratio of 30% EFLH. And then the second part of the financial model is to calculate the power consumption of the IEC hybrid unit and the DX unit, and then calculate the electricity cost of both machines over 15 years. And then complete the water consumption. Of course, water consumption will be for the IEC machine only. And then we calculate the water cost, and we see this difference in cost over 15 years. And then we put them all together and see the net cash of the unit when you add to it the maintenance. And we arrive at this rectangle at the very bottom of this page. NPV was 39,218 pounds. This is the difference in cost after 15 years, the net present value after 15 years. We found out that the IEC-H machine is cheaper by about 39,000 pounds. So that's one advantage. The second one is that you can achieve an IRR, which is an internal rate of return of 39%. Usually in Egypt, if your rate of return, your IRR, is higher than the interest rate with which you borrow money by about 5%, then you are doing very well. So when we are doing the test, the rate of borrowing was about 16%. So if you are in the region of 21%, you are excellent. But here, it's 39%, which is quite remarkable. And then we've seen the break-even point, where the money will come back to whoever buy IEC-H unit. After how many years of operation, you'll get his money back. So the break-even year was 2 years, and the fractional after 2 years is 0.41 years. So the result was very encouraging. In the end, to sort of summarize in a quick fashion, the summarize of the financial study is that the NPV was 28,000 and a bit, the IRR was 35%, the break-even year is 2.75. You see here I used a higher higher IRR. So in order to see what EFLH, how many hours per year the machine should work, and what would be the return under different hours of operation, this is called the sensitivity analysis. We find out that if it works, the EFLH is 30%, then the payback is 2.75, and the very important IRR is 35%. If you decrease operating hour per year to 25%, then the NPV decreases, becomes 11,200 and a bit pound, and the payback period is longer, it's 3.62 years. If the EFLH is 20% only, then the IRR is lower at 16%, and the payback is 5.32 years. But if you increase the EFLH to 40%, then the payback is 1.85 years fast. And the IRR is 51%, very high. And if you increase it to 50%, if the machine is working 50% of the year at its full capacity, then the NPV is about 100,000 pounds and the payback is only 1 year 39. So in other words, even with 26% EFLH, the machine works. When you go down to 16%, then it's not really worth it. But anything over 25% EFLH, the very important EFLH, it's an advantageous system. Now, those are the constraints of machines. They are full fresh air machine, primary air, outlet cooling, compressor size differ between the different OEMs, and we have the confidentiality clause in the contract between UNIDO and the OEM, that we are not going to see that this certain company or that certain company is better or worse. No. The idea was to try to introduce a new technology, not in-kind technology, طريقة تبريد غير نمطية, to the market and try to learn how to do that. So we were not interested who's better and who's worse. In order to give you a very quick idea, to give you a very quick idea of what we got in the end, we have here graphs that shows the red point there, show us the dry bulb temperature and the exit temperature of the DX machine and the IEC machine. They are almost the same. And then here you see the different wet bulb temperature, and the E is a very important EER. The EER in blue is EER of the IEC-H machine, and it's always higher than the EER of DX machine, which is the whole idea. Now, to move to the end results, if we compare the EER at climatic zone of the 4 manufacturers that work with us, you'll find that you have a blue line and a green line. So OEM2, the EER, the blue line, was higher than of the unit than that of the DX machine just next to it. One is 18.17, the other one is 15.63, so it's better. I'm talking about the blue because the blue is the high. There a high EER at the zenith of the day, and the lower EEI where the humidity is higher at night. Look at OEM3. Again, the EER is higher of the IEC machine for OEM3. OEM4 at climatic zone 2 had a problem with the machine, so we didn't put it inside our graphs. And then the last one, EEM7, we had a higher EER at climatic zone. So this shows that the EER is higher at climatic zone of all the unit. Now, the capacity is also higher for IEC machine, higher than a DX machine, yes indeed. And if you look at climatic zone 5, which is the lower humidity zone, again the EER, the blue, is all higher than the one of the DX machine. If you look at the capacity, again it's higher. So from either way you look at it, the test was successful for all 4 manufacturers. The EER was higher, the IEC machine, than the DX machine, and the capacity was higher for IEC machine than the DX machine. Does that mean we finish our test? No. we need to decide the size of the compressor, which varies from manufacturer to the other. This we didn't have the time to do that. So this is the next step, we hope. And then, as a conclusion, we see that the ER is higher. This is a good machine because it has a lower net pressure value and a high ER and a high capacity. We are hoping that we will be able to do tests in the two hotter climate zone of Egypt, climate zone 8 and 4. And I thank you very much.
We can open the panel for questions. Please, Mr. Javid.
Thank you very much for sharing.
Nice to see you, Carl.
Thank you so much. Thank you very much for sharing this huge efforts and all the results we have seen.
Thanks the Egyptian UM, they're the ones that make it. I just sat there and wrote some they're the ones that. Thanks Delta, thanks Tiba, thanks all the great Mahmoud Fikri. Those are the real, thanks HBRC.
All our partners as well. So thank you very much indeed. So sir, that the IAC results are showing this better ER, better capacity. So what is the roadmap you are seeing with the Egypt market for the adaptation perspective?
We are hoping that if we have a second phase with a test at the highest, zone 8 and zone 4, we'll be able to do a guideline for this recooling. And then I'll change it into a code. And then we get the parliament to agree on it, and then it becomes obligatory. So this is what I'm hoping for.
We'd like to thank our very dear Professor Alain for his precious lecture and precious information. We have another question from dear Engineer Yasser. Please.
Thank you, Dr. Alain, and support of this project, one of the participants. As we said, this is 100% fresh air equipment.
Yes, sir.
So all the results will be more efficient when you go to a hotter climate.
Indeed.
When you go to a hotter climate, the DX or the pure DX will consume more electricity because of the high ambient.
Yes,
And the evaporator will be very, very efficient at that zones. So the gap between the normal DX and the evaporator the gap will be very big. And at that time, you can see that the two-stage hybrid evaporator is a must. There will be no comparison. If you just compare in zone, as we said, in zone 2 and sometimes in zone 5, which it's not so hot and it's a bit humid, the comparison is goes for the evaporator. But if you go for the hotter zones, there will be no comparison. It's very clear that don't go for the X, go for the evaporator directly. So please, you need to make the test in the zones which is very hot and very humid, and for
Which zone, ASHRAE? Which zone would you like to see the machine?
Go to
South?
yes.
Aswan? Toshka?
All these hot zones.
Yes.
Because a hot zone is hot and dry. So for the evaporator, this is the
Ideal.
place.
Yes.
And very, very inefficient for the games.
Thank you very much for a very, very important comment, and I salute you and I salute your efforts. That you are a pioneer of the subject, and thank you very much for what you said.
Okay. I'd like to ask a question about the performance of the machine. So we compared the capacity of both machines and we found that it's comparable. But what about the sensitivity ratio or the sensitivity factor of the machines? Does both machines cover the related group in the same magnitude, or is there a difference in the related group?
You cannot compare an IECH heat ratio with the DX machine simply because the process is different. You are cooling first adiabatically, and then you are cooling on a constant dew point temperature line. So it's sensible, if you like, at the first stage. And then it's the humidification on the second stage, and a bit of cooling. And then on the third stage, which is the DX coil inside the machine, you have another cooling in between. So the heat ratio is a bit But in the end, to us, the overall refrigeration capacity is really things that you had to look at more than anything. Yes, sir.
Sorry for interrupting.
They're going to kick us out soon, and they're going to hold me here. The army is going to take me here. So, one last question.
Regarding the hot and dry zone, if we go for evaporative cooling, this for sure will be very efficient, and that zone is very dry, so we need the humidification for the concrete.
Reheat.
Yeah, I mean, normal cooling will decrease the water content, so maybe the rate of humidity is not sufficient at that time. So this will have both effects, cooling and humidification, which is needed for the dry zones.
Thank you, sir. Thank you.
Thank you, Engineer Yasser. Thank you for all the questions. We'd like to thank our Honorable Professor Alain for his lecture. And this is the symbolic certificate from ASHRAE College. Thank you, Kevin. Please, we have photos.
تدوير يا جماعه المعرض جاي بالتسعه بالظبط